I don't know what it is about this class. What is the domain? Well, we know that the denominator can't be 0. So the domain is all real numbers except for x can't be 1. That means that the VA is x equal 1. And, well, I'm going to come back to this, but what's the end behavior? Well, the end behavior is going to be x squared over x, which is just x. This is degree 1, which means it's an oblique. Now remember, we find the oblique, divide the denominator into the numerator, so it's set up for synthetic, which makes life nicer. Whoops. This should be a 1, and then a 3, and a 2. So bring down the 1. 1 times 1 is 1, and add. That's really all the further I have to go because I don't care about the remainder. 1 times 4 is 4, and add. The fact that I have a remainder means that the numerator and the denominator are not factors of one another. If this remainder were 0, that means I could have divided out the denominator. Then that's what becomes the hole in the graph. And this is x plus 4, so it's y equals x plus 4. See, another way to check this so I know it's not a hole in the graph, if x can't be 1, that means that a factor of the numerator is not x minus 1. In other words, I'm not going to have a 0 over 0 form. So 1 plus 3 plus 2 is not 0. So that says the denominator and the numerator are not factors of each other. Even though the numerator factors, by the way, and x plus 1 times x plus 2. But it's a plus 1, not a minus 1. So what do I do? Well, I take my graph paper, and now I'm going to draw what I know. I know I have a VA at x equal 1. So by the way, what makes these graphs so easy? I have an OA at y equals x plus 4. So it's got a y-intercept of 1, 2, 3, 4, and it has a slope of 1, which means it's over 1 and up 1, over 1 and up 1. And this is y equals x plus 4. It forms an x, so I know the graph is either inside the x or outside the x. And now I just need to know what part of the x it's in, and if I'm lucky, I'll have x and y intercepts, and that will tell me. X-intercepts basically is where y equals 0, or that's where the numerator, x squared plus 3x plus 2 equals 0. This is x plus 2, x plus 1 equals 0. X is negative 2, x is negative 1. So it's negative 2, 0, and negative 1, 0. Y-intercept is where x equals 0. So that's where we're going to have 0 squared plus 3 times 0 plus 2 over 0 minus 1, which is 2 over minus 1, or minus 2. So it's 0 minus 2. So 0 minus 2, that puts it firmly inside. And then I have a minus 1 and a minus 2. Those are my two x-intercepts. Puts it firmly inside. So this guy's going to come up. I don't know where the maximum is. I just do the best I can. It's going to ride up along, turn, come back down along the VA, and then its mirror image, and just plop it on the other side. Now, when you're in a calculus class, by the way, it's easy then to find where these humps are. And that gives you a better look at the graph. But we don't have those tools available to us. So I know the graph is either inside the x or it would be outside the x. They're all very predictable graphs. That's your graph with an OA.